I've shared a worksheet of how to go about writing your own functions to get you started. So let's go over this with a couple examples. So first, open up PyCharm and create a new Python file. So I'm going to call mine practice. Okay. And to help ground going through this worksheet, I'm going to start with the problems. Okay, and then I'll go over how to go about it. So the problem is to write a function pyramid that takes a single character and a number as parameters and displays an ASCII art pyramid to the screen with number rows. Okay, so I'm going to go ahead and I'm going to type out a leading comment right at the top of my program, which has this problem. And in general, it's a great practice to write out the problem that you're trying to solve right at the top of your program. That way you won't forget what you're trying to do. And so it also gives you the leading comment and a summary. And don't forget, I always put my author information there as well. Okay, so let's go through this process. So first I'm writing out the leading comment information. Now I'm going to try and write this function. And so I need to give it a name. Now the good news is the directions have already told me what the name is. And in fact, if the directions for the problem include name and parameter information, you should probably include it too. Okay, so the definition is pyramid. And next, I'm going to identify my inputs and outputs. And here I don't mean input from the user and printing out to the user necessarily. I mean, what are the parameters and are we returning anything? So the first question I have is it fruitful? You know, is the result of my function a value, or is it taking action like printing to the screen or drawing something? In this case, it's not fruitful because the result is to print something. And so the opposite of fruitful is void. So we have a void function here, so there's no return. Okay. Now, what changes versus stays the same? So this is really where we start facing challenges in functions. It's because we have to somehow generalize and abstract and figure out how we can write code for all of these different examples. But here we can see that there are two parameters, so we don't have to come up with that on our own. So we have a character and a number. And so I already have the answer to that. However, the purpose, let's imagine you're going to write your own function that we didn't have these parameters defined for. We would have to sit down and figure out what about this problem stays the same, what changes. And one of the ways you can do that is to actually write out the code to print this pyramid, or print this plus pyramid, or print this pyramid of x's, and then look at the code you wrote and see what's the same or different. So let's go ahead and kind of jot down what that might look like. So I'm going to do that over here so that we can see what that might look like. Probably need a moment while I make it look appropriate. Go. Okay. So imagine we'll have a def pyramid right here. Let's just print out right here. So if I look at these two stars here, I mean, I can simply print star, and then I'm going to print star times 2. Okay, well, that's not really a way that I can generalize. So I'm going to keep going. Let me see if I can print out these pluses. You know, there is some repetition here, right? I'm printing out pluses in each row. And so instead of printing one line after the other like I did up here, I'm going to try and use a for loop to do this. I'm going to say for I in range, and I'm starting with 1 star, and I'm going up through but not including number stars. So I'm going to print plus times I, right, the number of stars each time. Okay, and now let me try to write out the code that would print out this pyramid. And again, I'm going to use a for loop. So for I in, maybe we'll say for j in range, just to be different. J in range, 1 up through, but not including the last. So I go one more. I'm going to print x, times j. All right, so now I'm hoping that you're starting to see the patterns. There's a couple insights that I'm hoping you grasp. First is recognizing repetition. Even though this repetition isn't identical, right? We're not looping over the same number of elements being printed on each line, but there is a consistent pattern here. So you do have to recognize the pattern. That's part of programming, and I'm not sure I can break that down for you because each problem is slightly different. So I can't really break that process down further. But once you recognize that we have a loop here, that there's repetition needed, now you can look at, well, how are these two loops the same? How are they different? And so if you can identify what's the same versus what's different, that tells you what goes into your function versus what becomes parameters. So for example, here I can see what I'm printing becomes a parameter and how far I'm going becomes a parameter. And in fact, if you've done this well, you should even, in essence, be thinking through your implementation, what that looks like for the final version. Here, I did it very simply. So let me go back and update this. I think I can follow the same pattern I had before. So for A in range, I start at 1, I go up, I go one more, then the parameter, and the print is the same. Star times A. And if you wanted to verify this and double check, I would recommend copying and pasting these examples into your PyCharm and testing them and making sure that they work appropriately. And then you've got your function already debugged and ready to go. Okay, so I'm going to take this information, and now I know what my inputs and outputs should be. So which aspects of the code will stay the same, which bits will change. We wrote out the code to implement these 3 or 4 situations, and we identified what was similar and different about each case. And then what's different, again, becomes your parameters. The last step is to name your parameters, your inputs and outputs. We use meaningful names that capture the essence of our parameters. These were given to us, in some sense, by the problem, although single character wasn't named. I did have to name that, so I chose to name that parameter care. Okay? And finally, create your method stub. So we filled in the parameter names, and there was no return, so I don't have to fill in anything there. Now, at this point, you probably know enough. You could sit down and you could write this function. But what I'd like to do is show you this process on this worksheet, because this is a general process you can apply in any situation, and it's a very good habit and way of developing functions. So let's just keep sticking through with this, because actually implementing our function's body is the last piece. What I'm asking you to do next is to write your test cases. And so when we're creating a function, we have to call it or test it with a number of different parameters. In fact, that's what I've in essence given you when I say example call and return their displays. I am giving you test cases with known outputs. Your solution should meet this specification. Your solution to the function, when this is called, should output this. These are your tests. These are your test cases to make sure your function is working properly. And what I'm asking you to do here is to actually write your test cases before you write the code. This is a technique called test-driven development, and it's a very good process for incrementally developing your code and avoiding bugs, or when you have bugs, right? Bugs happen to everybody all the time. But the idea is that we control when bugs can be introduced in a way that makes them very easy for us to solve. So we never have to sit there and grapple with, oh, where is this bug? Oh, I don't know. It's 3 a.m. and I bang my head against the wall and can't figure this out, right? We want to avoid those situations. Okay, so let's go ahead and write out our test cases. And in this case, I'm going to put those in a main function. Now, main in most programming languages is a starting point where you would begin execution. So I'm going to call pyramid star 2. I'm going to call it pyramid plus 5. And finally, I'm going to do X. Okay, so these are the calls I need to the pyramid function. And if I want my test cases in main to be run, I also need to call main itself. And so I'm going to put that call down at the bottom of the program. Now Python expects me to actually have a body of my void method. So what I'm going to do is just do an empty return, just so I can practice and run this program. Okay, so I'm going to run practice, and nothing happened, and that's exactly as it should be. But really, when I'm testing, I want to indicate what's happening. So to help me do that, I'm going to actually print out the function call and then call it. So I'm going to print pyramid. Let's see. Now I'm not printing out the void function. I'm simply printing out the call. Oopsies. Alright, I want to copy and paste it as well. So in essence what I'm doing is I'm printing out the function call, and then I'm making the function call. And this is how I'm going to make it easy for myself to see as what the output should be when I'm testing. Okay, so let's try this again. Let me run. Good, and so now at least it tells me what I'm calling, and now it's up to me to fill in this empty return for this void function with what I should actually be accomplishing. Okay, if we go back here, so we wrote our function calls and we printed out the results to help us figure out if the results are correct or not. So if the test cases pass or they fail. And so I've simply done this just by noting to myself what calls are happening at the moment. Okay, and so now, and I ran my code with the default value for my void function, and now I'm going to incrementally implement the function's body, continually writing the code the whole time. However, in this case, we've already figured out what the body should look like, and it's a very small for loop, so I probably can only implement that piece. So for I in range from 1, and I'm going one more than number, right? 2 plus 1 is 3, 5 plus 6, 5 plus 1 is 6, 10 plus 1 is 11. So I'm going to go to number plus 1. So for I in range, and then I'm going to do my print. So I'm printing pair times that number. Okay, let's play this and see if we get the expected output. Awesome, and so what I can see is that when I call star2, I'm getting the appropriate pyramid, same with plus 5 and x10. I can clearly see that my output is as it should be. Okay, so now that we've completed the first exercise, let's try this again with a second exercise. And I highly recommend that you go through the worksheet on your own first and try to tackle this problem. And you pause the video. Okay, so now we're going to look at a function called absolute difference that takes two numbers as parameters and returns their absolute difference. Now, I could create a separate program to test this out, but I'm going to show you how I can add this in. So I'm going to actually move my leading comment to just before my function and change my leading comment now because I'm going to add this second function to my program. So here this is going to be writing functions practice tutorial. Okay, so I'm going to use this as a comment. Now, typically, all functions are defined before main. Usually main is defined last. And all of your functions should come before any code that's unindented and not def. And if I had imports would go here. And so it's important when you're communicating with other programmers and writing code for other programmers to read that you follow this standard template so that everybody knows where to find the code they're looking for. Okay, so I'm going to define a function, absolute difference. Let's see, I'm following along my directions. Right, so I didn't have to pick the name. Now the question is this a fruitful or a void function? Well, let's read the directions. So write a function, absolute difference, that takes two numbers as parameters and returns. So this is a fruitful function. Now what is going to be returned? We are going to return some kind of a difference. Okay, that's the variable that we'll be returning. So what changes versus stays the same? Well, if I look down here, I'm always finding the difference. So 10 minus 5 is 5, 10 minus 5 is 5. So what stays the same is the difference. The parameters are changing. The values that I'm subtracting to give me the absolute difference. Okay, so those become the parameters, which I have actually specified down here in the example. I know I have two numbers as parameters. So num1 and num2. I could make those more meaningful names. Number 1, number 2. I could just use simply x and y, a and b, as long as it's clear. Okay, so I've named my parameters, named my inputs, and I've also named my output. I think difference capture, I could also call it diff, right, to be kind of shorthand. And now I need to finish creating my method stub, or my function stub. So I'm going to fill in the parameter names and create an output variable, which I've done here, with a default value of the appropriate type. So absolute difference is taking two numbers, and the result should be a number. So I am going to simply plug in, the default value here, diff equals 0, return diff. So this is my stub, right? So this is a placeholder function, so I can write my test cases, but that's not actually, it's not. I don't expect this to actually work. So now I'm going to write my test cases. I'm going to do this in main. I'm just going to add this code right above. Okay, and I have my test cases down here, in fact. Let's see. So I want to write something. So I'm going to say difference 5, 10. And I'm just going to pick, I want true and false to be output in this case. So I want to see that this is equal to 5. And I'm going to copy and paste this. And so I'm hoping you're seeing a little bit more about what I mean with how to make your test cases human readable, right? So instead of having to manually check is this what's output by absolute difference 5, I'm putting the equivalent in here, so I'm just looking for true or false. Okay, and then lastly, there's 200, negative 200. And this output should be 400. Okay, so let's make sure we run this. I have an extra print here just to kind of separate out between our new and our old code. Let's run it. Okay, good. All of them fail. They're all false. And that's exactly as it should be because I haven't actually implemented absolute difference yet. Okay, so the way I can do absolute difference is I'm going to take the difference between 1 and 2, but I'm also going to take the absolute value of the result. And if you wanted, you could simply return what's on the right-hand side of this equal sign. And if I look at my results, they're all true. And so I hope that you'll find this approach to writing functions useful and systematic so that you don't end up in a tangle of challenging debugging.